All right, so we're talking about secants, tangents, and angle measures as they relate to each other in circles. Okay? Requires one bit of new vocabulary here, and that is the idea of a secant line. We said yesterday that a tangent line is a line that intersects a circle at one point. Yeah? A secant line is any line that intersects a circle at 2 points. So we have two lines in that picture to the right, line J and line K, both of which are secant lines to circle C. They intersect circle C at 2 points, which makes them secant lines. Now basically we're going to be dealing with three different rules in this section, because when we talk about secant and tangent lines and how they interact with each other in or around a circle, there are three ways they can intersect. They can intersect inside of the circle, they can intersect on the circle, and they can intersect outside of the circle. So we have one rule for each of those situations. So we start with, what do we do when a pair of secants, or a pair of chords, intersect inside of a circle? Well, that's where our first theorem comes in. Okay? It says if two secants, or chords, because chords would be part of secants, intersect inside of a circle, then the measure of the angle formed is 1/2 the sum of the measure of the two intercepted arcs. So I want to explain that a little bit differently. Looking at the picture on the lower right. Okay, we've got those two secant lines that are intersecting to form angles 1 and 2. Correct? Looking at angle 1, would you agree with me that this angle has the same measure as angle 1? Why? Good, they're vertical angles. Now those angles are intercepting these two arcs. Arc AB is being intercepted by the top angle 1, right? And arc CD is being intercepted by the bottom angle 1. Yes? Now we do not know whether or not that point of intersection is the center of the circle. Correct? In fact, it pretty clearly is not the center. Yes? So it's not like central angle where it just is the angle. The angle and the arc are not necessarily the same. Instead, what we're saying here is that the measure of angle 1 is the average of the measures of those two arcs. So we add those two arcs, AB and CD, together and divide by 2 to average their measures. The average of their measures is equal to the measure of angle 1. Now we can make the exact same argument for angle 2. There are really two angle 2's in this picture because of vertical angles. Yes? And those two angles intercept arc AD and arc BC. So the same idea would apply here. The measure of angle 2 would be 1/2 the measure of arc AD plus the measure of arc BC. So when they intersect inside of a circle, we add the two intercepted arcs together and divide by 2. So let's take a look at some examples here. Here are 3 examples of applying this rule to a math problem to find x. Letter A is extremely straightforward. Okay, that angle marked x is the angle that is intercepting these two arcs. Yes? So we would say x is 1/2 the sum of those two arcs. So x is 1/2 of 84 plus 130. That would be 1/2 of what? 214? So x would be 107 degrees. Now on the surface, that's a relatively simple rule, which means the question arises, as it always does, how are we going to make that harder? Because let's be honest, math teachers love to try to make things harder than they need to be. Well, the other two examples are excellent ways that I could apply the same rule in a slightly different way. For instance, on letter B, angle X is not the angle that we know the arcs for, is it? But using our rule, we are able to find this angle, which I will call angle Y. Okay? We can find Y, because Y is the angle responsible for intercepting the two arcs that we know. Would you agree with me on that statement? So we find that angle. We say, all right, well, Y has to be half of the measure of arc AB, which we know, and CD, which we know. So if I add those two arcs together and divide by 2, I can find angle Y. So let's see, that's 143 plus 75 are the two angles. Add those together. That's 218. So Y is half of 218 degrees, which would be what, 109? And while that's wonderful, that's not the answer to the question. However, how do we use Y to answer the question? Supplementary. They form a linear pair, X and Y. So X would be 180 minus Y, or 71 degrees. So that's one way it can be made harder. Okay, the other way that we can make it difficult is shown in example C, where the X is not the angle, but is in fact one of the arcs. Yeah? These are the two arcs intercepted by 110 degrees. Well, that doesn't change a whole lot, except we have to solve. We end up with the angle 110 degrees is half of the sum of the arcs, or x plus 97. And then we have to solve that equation. So, how do we solve that equation? How do we get rid of 1/2? Multiply by 2. We'll go 110 times 2 and 1/2, that cancels, which gives us 220 equals x plus 97. And then, good, subtract 97. So 220 minus 97 is 123 degrees for our x value. So there's 3 good examples. On the next page are 3 more. Please try them on your own. If you're watching the video, pause it and try them on your own, and then resume the video. So try the 3 on the next page, please. Okay, so these are just 3 more examples of the same basic idea. So on the first one, we have x is the angle, being it is intercepting these two arcs, so all we need to do is add 47 and 116 together and divide by 2. So 116 plus 47 is 163, and half of that would be 81.5. So x is 81.5. On letter B, we can't find x, so we find y instead. So y would be half of 55 plus 75, meaning that y is half of 130, which would be 65. But y is not what the problem asked us for. It asked us for x, which is the supplement of y. So we do 180 minus 65, and we get x is 115. No. No. And then C is another example where x is one of the arcs. So the angle, 128, is equal to half the sum of the arcs. So half of x plus 154. We would double both sides to get rid of the 1/2, so multiply by 2, which gives us 256 equals x plus 154. And then we would subtract 154 from each side, giving us x is 102 degrees. So that's how we handle two secants intersecting inside of a circle. Okay, so our next situation, we've talked about what to do when they intersect inside of a circle. Now we need to talk about what happens when we have a secant and a tangent intersecting at the point of tangency. So notice that now our secant and our tangent are going to be intersecting on the circle. Look at that picture, okay? If a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is half the measure of its intercepted arc. Now, what do I mean by that? Basically, these angles, 1 and 2, behave like inscribed angles. They are exactly half of their intercepted arc. So if you look at the equation here, the measure of angle 1 is half the measure of its intercepted arc AB. It is half of that arc, just like it would be if it was an inscribed angle. Same thing for angle 2. It is exactly half of arc ACB. Okay, so all we need to do is realize that arc is twice the angle, that the angle is half of the arc. So a couple examples again, measure of PQ or QPR. That's this angle right here, QPR. The measure of QPR is equal to half the measure of its intercepted arc, which would be arc PR. This arc right here would be the intercepted arc. Well, that arc is given to us as being 148 degrees. So we're doing half of 148 degrees is all we need to do. Just need to do 148 divided by 2. So the measure of angle QPR is 74 degrees. So again, that's pretty straightforward on the surface. It doesn't look like it's ever going to be that tricky. So the big question is, how am I, as your math teacher, going to make it harder? Well, the second example is asking us to find arc DEF. Is arc DEF the intercepted arc for the angle? No, DEF is the rest of the circle. So what should our approach be here? Okay, we should find the arc first that it does intercept. We should find arc DF, the minor arc. Okay. The measure of angle FDC is half the measure of minor arc FD. Well, we know the measure of that angle. It's what? 64 degrees. So we have 64 degrees is half of arc FD. What is arc FD then? What do we do? Yeah, it's twice that, 128. We multiply both sides by 2, And we get that this angle, or this arc in here, is 128 degrees from F to D. Now, that's lovely, but we weren't asked for the minor arc, were we? We were asked for the major arc, so what do? Subtract that from 360. Outstanding. The measure of the major arc, DEF, is 360 minus the minor arc. Okay, the major arc and the minor arc connecting FD add up to 360 degrees. So now that we know that the minor arc is 128 degrees, it is relatively simple to find the measure of the major arc. We just need to do 360 minus 128. Which is 232 degrees. That would be the answer to the question. That's the measure of arc DEF. So again, there are two more of these on the next slide. I'd like you to try them. If you're watching the video, pause it and try them on your own, and then resume the video to see how you did. So on 2A, we're asked to find the measure of arc JLK. That is the intercepted arc for the angle that is provided. So we need to realize that the measure of angle HJK, which is the angle we are given, is half the measure of arc JLK. So 116 is half the measure of the angle we're asked about. So to get that arc that we need to multiply both sides by 2, which means we are getting 232 degrees for the measure of arc JLK. On 2B, we're asked to find the measure of angle RQS, and they've given us the major arc measure is 238 degrees, QTS. So if QTS is 238 degrees, what is the measure of arc QS, the minor arc? How do we get it? Yeah, this arc, whatever this arc measure is, would be 360 minus 238. That's what, 122? Okay, so arc QS is 122 degrees. Well, the measure of angle RQS is half the measure of that minor arc QS. So the measure of the angle that we're trying to find is half of 122 degrees. That would be 61 degrees. Okay, so that takes care of intersecting on the circle and leaves us with one situation to talk about, which we are going to be covering in our next class period. Okay, that is where we're going to pause for today. That's where this video will end.